This is a video on finding the derivative of an inverse function using the second fundamental theorem of calculus. The question states, let f of x equals the integral from 3 to x of e to the t over t dt. Find the derivative of the inverse function of f evaluated at 0. The way we do this is we use the derivative of the inverse formula, which states that the derivative of the inverse evaluated at a number is 1 over the derivative evaluated at the inverse of that number. So we need to find the derivative and the inverse. For the derivative, we can use a second fundamental theorem of calculus. F of x is an integral from a number to x of an integrand. So the derivative is just plugging in x into that integrand. Or in other words, f prime of x is equal to e to the x divided by x. Now let's find the inverse of f evaluated at 0. And to do that, we say, what number x will give you 0 when we integrate? And take a look at that. We're integrating from 3 to x of a function. Well, we know that if we integrate from 3 to 3 of a function, you always get 0 because the integral from a number to itself is always 0. So in particular, x is equal to 3. So now we're ready to plug in to our formula. The derivative of the inverse at 0 is 1 over the derivative of f inverse of 0, and f inverse of 0 is 3. So I now plug 3 into f prime. So we get 1 over f prime of 3, which is e to the 3 over 3. And of course, 1 over e to the 3 over 3 is just 3 over e cubed. And I'm done with the problem.